Okay, so today, April 13, happy Thursday. Today, according to our calendar, it says we're tackling lessons 20 and 21. This says we are finishing lesson 20. That is not the complete truth. We actually didn't start lesson 20 in our last class before the quiz, so we're doing all of 20, all of 21, but I think we'll be able to hack it. These two sections are not, they're not all that long. Okay, so that's the plan. We've got no assessments coming up until quest number 4 on April 27th. So it looks like 2 weeks from today is our next quest in this class. Any questions on the calendar? You do, yeah. The final date is May 16th, 10:30 to 12:30, right here in this room. Put it in your calendar. And this is on the back of your syllabus that you have a copy of. Other questions? Okay, so here we are on 161. All right, so our daily summary. In this lesson, we learned how to factor the difference of two squares and quadratic trinomials where a is not equal to 1. So that a business, actually I don't even know that we've seen it at this point. But ax squared plus bx plus c, a is the first number, the number touching the x squared. So we'll talk about these guys. How about before we do this, this factoring thing here, let's remind ourselves. Let's just jump in on the next page and 2 pages away, actually. 163, can we do this one to remind ourselves? It's been a week since we've done any factoring stuff together. So let's jump in here. Okay, so here is the question. The question is, can you factor 6x squared minus 11x minus 10? What that means, I'm going to put the answer, although it's going to be the wrong answer. I'm just going to like make up an answer. 4x plus 7 times 3x minus 2. That is the goal. The goal is to write that 6x squared minus 11x minus 10 as the product of two things. They're called binomials, those two things. Now, this is not the right answer. We know, like foil or lobster claw, you could also use a box to do all the distributing through there. If, for example, you multiply the first times the first, what do you get? 12x squared, which is not 6x squared. That is not the right answer. I just made it up, but that is the format of the right answer. That is the goal that we're after, okay? But actually finding the right answer is this whole page process that we're going to remind ourselves of. Okay, so the process. We draw this little 2x2 box. You take the first thing, that's 6x squared. Do you remember where it goes? Top left. Put 6x squared right in there. Go ahead. And then we take that middle thing, that negative 11x, and I'm just going to write it down here next to the word sum. Sum of two things is supposed to be negative 11x. We're going to get more information about that. Okay, where does the negative 10 go? Bottom right. So you take your three things. You're always going to have three things for this kind of factoring problem. You put them in exactly those spots. And then the next thing that we do, I'll put this down here, is the word product equals. And we just multiply that one diagonal that we have. 6x squared times negative 10 is negative 60x squared, okay? Don't lose sight of the goal. I know there's a lot of steps in this process. It's one of the more complicated processes from our entire semester, but the goal is to get these two things in the parentheses. It's not those, it's two other things, but that's what we're after. This process is going to build those two things. Okay, so now we got to play detective. This is the hardest part of this long process. We are looking for two things. We're going to put them in the empty boxes here, whose sum is negative 11x and whose product is negative 60x squared. Two things that add up to that and multiply to that. For example, don't write this because it's wrong, but for example, negative 13x and 2x. Do they add up to negative 11x? They do. Do they multiply to negative 60x squared? They do not. They multiply to negative 26x squared. So that's not the right answer. But I did make up two things that add to negative 11. But if you remember from a week ago when we did this, there are infinitely many things that add up to negative 11x. I just picked one of them here, but I could have done like negative 14x and 3x, negative 15x and 4x. There's no limit to the end of that. But over here, there is a very small collection of things that multiply to negative 60x squared. So even though we wrote the sum first, you got to focus on the product first. You list all the different things that multiply to negative 60x squared. So for example, 1x and negative 60x. That multiplies to negative 60x squared, right? 2x and not 30, but negative 30. Got to make sure we get the sign. It needs to be negative 60x squared, right? And there just isn't that long of a list of things that multiply to negative 60. You're going to run out of them pretty quick. So let's save ourselves a little bit of time. I actually typed this up already. There's the complete list. We had just written down the first two, but there's the rest of them. And there's no more, right? Like once you get up to 6x and negative 10x, then you just got to repeat with the same numbers, but put the negative on the other term. And that is it. It's a list of 12 possibilities. And if everything is going to work out, then one of those 12 things is going to have the right sum, negative 11x. So you just zip through. You can add them all up one at a time if you like to be methodical, or you can just kind of jump around if you're feeling like you might be able to find the answer quicker that way. But you're just looking for the things that add up to negative 11x. Which one? 4 and negative 15. That's the one right there. What does it multiply to? Negative 60x squared. What does it add to? Negative 11x. That's the winner. And so we put those two things into the box. Don't put them in just yet. It doesn't make any difference what order you put them in, but let's all put them into the same order so that we can have the same answer on our pages here. So put them in that order, but when you're doing the ones in the activity, it makes no difference at all. 163. Okay, the next piece of this process is to look in the first row and factor out the greatest common factor. I'm coming right out here. So looking for something that goes into both 6 and negative 15. What's the biggest number that goes into both? 3 is good, just by inspection. And then the question is, can you also pull an x out of both of them? You can. They both have an x in them. Can you pull out an x squared from both of them? No, because that negative 15x only has a single x. It doesn't have an x squared. So the absolute most we can take out is 3x. That is the greatest common factor. Now this is an important, tricky moment to make sure we don't fall into a trap here. What we just did is factored out the greatest common factor from the first row. That is the only time we factor out the greatest common factor. We do not go to the second row and pull out the greatest common factor. We do not go to the first column. We do not go to the second column. The rest of this problem is solved differently. The other three things that we're going to put outside is not about the greatest common factor. That said, when I say I always start with the first row, that is an arbitrary choice. You can start with any row or column you want and pull out the greatest common factor, but the key is that you only do that one time. Pulling out the greatest common factor is a one-time only thing. If you want to follow me, just do the first row every time as a default. Next, we are going to go right up here on the top. And we are going to ask ourselves, we're not looking at the whole column. We're just looking at this single thing. And we're saying, hey, by the box method, I know when I multiply the two guys on the outside, it's supposed to build the thing on the inside. So what do I need to put up on top to multiply by the 3x and get that? It is 2x. Okay. And let's go ahead and look here and put this thing up on the top. What do I need to multiply by to get that negative? Negative 5 is good. Negative 5, squeeze that in there. Okay, and now we're going to look here and ask ourselves, what am I putting here? But now we have to use other stuff. The thing that builds this 4x is this guy and this guy, right? So 2x times what? 2 is good. I'm going to try to remember to always include the sign. Positive 2 in that case. I'm going to circle in green this last guy. I got no more freedom, nothing else to put on the outside. I'm done. But I do need to make sure that that minus 10 worked. Did it? If you multiply that and that, do you get minus 10? We do. If you don't, it means you made a mistake. It doesn't mean the method didn't work. It means you messed up someplace. Go find it, right? If you did everything right, that's going to work every time. Okay, and then we just have to grab the stuff that's on the outside, and that's going to be our answer. I'll start on the left. 3x plus 2. Put that in your first parentheses. And then reading across the top, 2x minus 5. I don't need you to do this in general, but it's been a while since we've done one of these, so let us just check our answer by doing the distributive property or FOIL or lobster claw, whatever you want to call it. Let's do it here and check to make sure that we get the right thing. The claim is that this thing right here is exactly the same as the product of those two binomials. Let's make sure it is. First times first, what is it? 6x squared, that's promising. So far, so good. Outers. Yeah, right, 3x times negative 5, that's negative 15x. That's good. Inners. Plus 4x, that's good. Lasts. Minus 10. Just as a quick aside, do you see exactly those four things in the box? And what do you get when you smush together the two middle terms here? Negative 11x, which is exactly what we were after. Factoring these problems is pretty tough, but we've got a process. It's got a few steps in it, but with practice, it gets easier. And hopefully it just gets to a place where you say, okay, I do this, then this, then this, then this, this. Okay, so that's a reminder from what we did a week ago. Let's go back 2 pages, back to 161. Okay, so let's multiply a few products. They're all going to have a certain pattern that we will observe. So again, we're doing the lobster claw or FOIL. First times first is x squared. Outers, negative 3x. Inners is a positive 3x. Last, minus 9. And as usual, we combine the two terms in the middle. And what happens when we do that? They cancel. And so we just get x squared minus 9. And the reason that they canceled in this case is that the things in the parentheses were exactly the same, except 1 plus and 1 minus. And that's what made the things cancel. Take a look here in part B. It is the same pattern. The two binomials in the parentheses are exactly the same, except 1 plus and 1 minus. You might have a sense of like a shortcut. What's the answer right away? But let's just write it out. First times first. 49. Outers. Positive 7y. Inners. Negative 7y. That's your cancellation. Last. Minus y squared. So this is 49 minus y squared. Okay, let's do one more in part C. Looks a little more complicated, but it is exactly the same pattern. Things in the parentheses are identical, except 1 plus and 1 minus. First times first. 2x times 2x. That's 4x squared. Good. Outers. Negative 10xy. We see it? All we can do is multiply the 2 and the 5. And then we just copy the x times y. Can't do anything else. Inners is a positive 10xy. Those will cancel. And then last, negative 25y squared. And so our final answer there, 4x squared minus 25y squared. Okay, so what we have discovered is a shortcut for multiplying two things that look exactly in that form. To be honest, this is not that big of a shortcut. Writing it out hardly takes any time. And then combining like terms, you get the right answer. Honestly, that is not even why I'm showing it to you. The shortcut that I'm showing you is actually going the other direction. If I give you this, and I say, hey, can you factor it into the product of two parentheses? I want you to be able to give me the original. And if I give you this, I want you to say, oh, 7 plus y, 7 minus y. That's where it came from, okay? So I'm not showing you a shortcut going the direction we just did. I'm showing you a method to go the other direction. So here's our formula. It is called the difference of two squares because there is a subtraction sign in the middle, and a squared is a perfect square and b squared is a perfect square. And when you see exactly that pattern, like 49 minus y squared, a squared minus b squared, you factor it as a plus b times a minus b. Let's use that formula to do these examples here. X squared minus 64, go ahead and write it this way. Give yourself the empty shell with the two parentheses. Okay, I see a subtraction, I see a perfect square, and I see 64 is also a perfect square. We got to start to recognize they're up here in yellow. Any perfect square is maybe a giveaway. Hey, it might be this fancy new formula. So where did the x squared come from? What and what? Definitely came from x and x. Where did the 64, forget the subtract, where did the 64 come from? 8 and 8. And it's important that you put 8 and 8. It is not the only way to get 64. 64 could have been, what, 32 times 2? But 32 times 2 isn't going to give you the canceling that we're looking for in the middle. You've got to pick the same number twice, which is why it had to be a perfect square. 64 was not just randomly chosen there. And then finally, 1 plus and 1 minus. It makes no difference what order you put the plus and the minus in. Okay, so this is the harder direction, factoring. Let's try this guy. Again, same pattern. I see two terms, I see a subtraction sign in the middle, and I see perfect squares all over the place. So give yourself the empty parentheses. Let's have you try this one on your own for just a moment, so don't say the answer out loud. But in the first blanks, you are putting two things that multiply to 100, but they better be the same exact thing. And the second blank is going to look a little bit trickier, but you need to, again, put two things that are copies of each other, but they need to multiply to a squared, b squared. Okay, so now out loud, what are the first two things? Tens. How are we going to get a squared, b squared? AB and AB, that's it. And what about the signs? 1 plus, 1 minus, easy peasy. Okay, let's take a look at C. We're gonna go through our same routine, like a batter in a batter's box. They got their routine when they get into the batter's box before they take that first pitch. Here's our routine. Is that two terms, 3r squared minus 27? Is it two terms? It is. It's not three terms. The first thing we did today was 6x squared minus 11x minus 10. I think that's what it was. That was three terms. That's not this. This is two terms specifically. Is it two terms? Yes, it is. Is it a difference? The subtraction sign in the middle? Yes, it is. Are both of the terms perfect squares? Is 27 a perfect square? No, that's the end of the game. We got to get yeses to all three of those questions in order to use our magic formula. So we cannot do the thing that we just did. 27 is no good. 3 is also no good. But here's the hint. We're going to first factor out the GCF, the greatest common factor. Let's do that. What goes into both? It's 3. Don't say out loud, but go ahead and put in the thing in the parentheses if you can. When you factor out that 3 from both terms. So I get r squared minus 9. Is that okay? Okay. And hey, r squared minus 9 is a brand new problem, and we can ask our same 3 questions. Is it two terms in the r squared minus 9? Yep. Is it a difference? Subtraction? Yep. Are they both perfect squares? They are, right? It's not 27 anymore, it's 9, and 9 is a perfect square. So give yourself the 2 parentheses. Go ahead and fill in. First terms had better give you r squared. Last terms had better give you 9. Got to be copies of each other. 1 plus, 1 minus. So r3, r3, 1 plus, 1 minus. What did I forget? The 3. You cannot lose the 3. All we did was the stuff in the parentheses. Once that 3 is in the front, it is forever in the front. So copy it down. Okay, part D. X squared plus 25. I see that 25. Immediately I'm starting to smell, oh, this is that perfect squares thing again, right? 25 is a perfect square. Is it two terms? Yeah. Are they all perfect squares? Yeah. Is it a difference? No. That's the end of the game. You cannot factor this. I'm going to write down some stuff that's wrong. Don't write it. If we were going to do our normal thing, it'd be like this, right? X plus 5, x minus 5. What do you get when you multiply the two last things? Negative 25. That is not plus 25. Okay, so it's not that. Another possibility. I'm going to write that guy. Sometimes people say, oh, I can fix that. I can make a plus 25. I agree. You have correctly made a plus 25. That's super. When you do the outers, what do you get? When you do the outers, what do you get? That's a negative 5x. When you do the inners, what do you get? Another negative 5x. Do they cancel? No. You correctly built x squared plus 25. But the problem is you left over a negative 10x in the middle. And we just cannot do anything. There's no like clever way around this here. So I'm going to put a big old X's through all of this. None of that is good. Here is our answer for this one. C, B, F. Cannot be factored. Cannot be factored. That difference of squares formula is a very particular formula. Only get to use it if some special conditions all hold true. This one cannot be factored. Okay, let's take a look at E. X to the 4 minus 16. Might be a little intimidating. We've got a lot of practice now with x squareds, not so much with x to the 4th, but it is two terms. It is a subtraction. 16 is a perfect square, and in fact, so is that x to the 4th. Let's give this a shot. Two parentheses. You got to put two copies of the same thing to give you x to the 4th. It's x squared. Two copies of the same thing to give you a 16. 4, 4. 1 plus, 1 minus, makes no difference the order. So this is correct, but it's not completed. Our goal is to factor as much as possible, and we can factor again. One of these can get factored further. Okay, take a look at the x squared plus 4. Why can we not use our brand new formula here? Because it's not a difference, it is a plus. So that one, we cannot go anywhere. Just copy it down. But the other one, x squared minus 4, is it two terms? Yeah. Does it subtract? Yeah. Are they both perfect squares? Yeah. So give yourself two blank parentheses, giving 3 altogether for this problem. See if you can fill them in. What are they? X plus 2, x minus 2, and that's as far as we go. Questions on that? Okay, a couple of observations here about this difference of two squares formula. You can abbreviate it dots if you want to, difference of two squares. Okay, dots only applies when you have two terms separated by subtraction, each of which is a perfect square. That is our routine, like getting into the batter's box. We got to get answers 3 yeses to those questions in order to use the difference of two squares. You cannot use the dots formula to factor a sum. I say again, you cannot use the dots formula to factor a sum. On the next quest and probably the next test and possibly the final exam, I am going to tempt you with a sum and say, hey, can you factor this? And some of you are going to say, oh, Ian would not deceive me like this. Of course we can factor this. And the answer is going to be, the right answer is going to be cannot be factored. Okay? Yeah. But I am very mean. Like I've already written the quest and test and final, so but I wrote them so long ago I don't remember, but I know myself. And I can just about guarantee you I'm going to give you something like x squared plus 49. And I'm so mean that I'm going to pick something like 49. Why is that mean? Because 49 is a perfect square. I'm going to tempt you with a perfect square. But that plus sign means you need to say no. Cannot be factored. Cannot be factored. Okay, that is the answer. That is an acceptable answer. Okay, and then it says sometimes you have to use the dots formula twice on the same expression. That's what we did in this last one here. Okay, if we're ready, next page. Okay, so you'll get lots of practice with the 2x2 box method in today's activity. We did one of those earlier. But we left out a small but important detail in our explanation of the box method a week ago when we first covered it. So consider the box at right. I've already done a bunch of the work for this one. It came from this negative 6x squared minus 15x plus 36. So I did all the stuff you can verify. Where would you put the first thing? In the top left, that's where it is, right? Where would you put the last thing? In the bottom right, there it is. You would say that this guy is really the what? Is really the sum. Now I've done the hard work, but if you do the sum of those two, did it work? Yeah, I put the right things in there. And if you check, it'll have the right product. 6 times 36 is 216, 9 times 24 is 216. Everything's working. So let's finish this problem, assuming it's already been filled in like this. So for me, I go the first row. Let's go to the first row. So what can we factor out? Greatest common factor in the first row. 3 is good. Anything else? X is good. That's it, 3 and X. It turns out if you decide you're going to factor out a negative 3x, that's totally fine. It's going to change the rest of the answers, but you will get a perfectly acceptable alternate answer to this one. Okay, so we've done that one. That was our first step. Now let's go up here. What am I putting there to build the negative 6x squared? Negative 2x is good. Oops, negative 2x there. Let's go up here, trying to build the 9x. Say a little bit more. Positive 3. Yeah, I think it's a good idea to include those signs. And then we'll come out here, and I'll point. Negative 2x times the blank. What is it? 12, say a little more. Positive 12 is good. Let's check our work. Do we get 36? Yes, we do. Okay, so everything is groovy. Let's fill in the parentheses with the stuff that's on the outside. So we go 3x plus 12, and then negative 2x plus 3. Yeah? Okay, so there's no problems. This is all correct. But you'd lose a point if you left this as your final answer, because the question that I'm going to give you is going to say factor this thing up here completely. Well, you have factored it, but you have not finished factoring it. Do you see that 3x plus 12 has a greatest common factor you could pull out? And so if you can, then you have to. What number can you pull out of 3x plus 12? It's 3. What's left from that 3x plus 12? X plus 4 is good. Can you pull anything out of the negative 2x plus 3? No, so we just copy that. But we do take a moment to look and see if we can pull anything out. So that's it. So just one last little step at the end of that big old box problem is just check your two things in the parentheses to see if you can factor anything out of a greatest common factor out. Now, I know that's a little detail, and it's just one more detail on this already long process. The fact is, if you do something ahead of time at the start of this problem, you're going to make your life easier. The whole problem will become easier, and you won't have to worry about this detail at the end. What we should have done, if I just gave you this thing and I said factor it, let's come down here to number 6. It says that we've got 3 different factoring techniques, and there is a particular order that I recommend you do the factoring on any problem. I'm going to give you lots of different kinds of factoring problems. Always go through this order. First thing is to always factor out the greatest common factor. That is always what we should look for first. Pull out the greatest common factor first, okay? All right, second thing, see if you can use the difference of two squares formula, dots, D-O-T-S. That is always number 2, greatest common factor, then dots, and then finally the box method. Try a 2x2 box if we've got one of our trinomials that we've been playing with, okay? Those are the 3 processes. There's a good reason the box one is last. It's the hardest, isn't it? Factoring out greatest common factor is pretty easy. The dots formula is pretty easy once you know how to use it. The box method is long, but some students start with the longest technique, and there's no need to do that. All right, let's go in that particular order. If you were to follow that advice up here on this negative 6x squared minus 15x plus 36, okay? What's the first step we're supposed to do here? Greatest common factor. What can you see that goes into the 6 and the 15 and the 36? 3 goes into all of them. So this equals 3 times. What's left? Negative 2x squared minus 5x. And then plus 12 there. Is that okay? Right. So we factored out the greatest common factor. And now we go through our routine. Difference of two squares. Can we do the difference of two squares on this stuff in the parentheses? No, it's 3 terms, right? It's definitely not that formula. And then the last thing is the box. So you do the box on the negative 2x squared minus 5x plus 12. And I'm not saying it's short, but would you agree that the numbers are better here than they were to start with? Like you're putting all, like I did 6 times 36 and I just said it's 216. I'm guessing not a lot of us knew that. And doing the factors of 216 is pretty darn annoying, yes? Whereas here, new box here, negative 2x squared in the one, 24 in the other, what's the product? Sorry, 12 in the other, what's the product? Is negative 24 x squared. Isn't it a whole lot easier to factor negative 24 than the negative 216? Yeah, and additionally, so not only have you made the entire box problem easier because the numbers are all smaller, but additionally, that 3 is exactly the 3 that maybe we would not have seen we were supposed to pull out at the end of this problem. So there's very good reason for pulling out the greatest common factor first, okay? All right, so why don't we start the activity here? At some point, I'll call us back together and we'll do the other lesson.